This movie presents two alternative scatterplot interaction techniques that allow the handling of many thousands of items on small screens. One is a geometric semantic zoom that provides smooth transition between overview and detail, and the other features a fisheye distortion that displays the focus and context regions of the scatterplot in a single view. The scatterplot currently displayed shows a visualization of a book database containing 7,500 items. Each book is represented by a gray pixel and mapped to a Cartesian position by the scatterplot dimensions of year of publications, x-axis, and sale price, y-axis. The year of publication denotes a date consisting of year and month ranging from January 1950 to December 2010. The sale price holds a value between 0 and 50 euro. The problem with scatterplots is that given standard database sizes, the display usually becomes crowded with data items, and thus overlappings cannot be avoided. In this case, the screen attribute characteristics amount to a potential information density of 150 items per pixel. In other words, one gray pixel inside the scatterplot may represent up to 150 books. The objective of the two interaction techniques developed is to prune visual clutter and to make each item easily accessible to the user. Geometric semantic zoom. The basic idea of the geometric semantic zoom is that users can control the ratio of overview and detail information by the degree of scaling they perform. The more they zoom in, the fewer items are shown, but more details are presented. The user starts scatterplot exploration by tapping a region of interest and holding the pen down on the display. As you have seen, after an initial delay of 150 milliseconds, a fluent zoom animation is triggered. Book representations that are far away from the focus item drift out of sight, while the focus item itself moves smoothly into the center of the view. While zooming in, the space gained through clipping is allocated to the remaining items and causes data clusters to scatter. That way overlappings are resolved. Moreover, and due to semantic zoom, the continuously increasing distance between items is used to change their appearance. Gray pixels grow to small rectangles and then to record cards, which are used to display information about the books they represent. Please also note that during zooming operations, scatterplot labels are rapidly continuously updated. To zoom out, users press the button below the diagram. As well as zooming, users can also pan the diagram via a pen gesture. Users tap the display and drag the pane in the direction they want to move the viewport. During panning, users can control the direction and speed through the pen position in real time. Another option for moving from one item in the view to another is to simply tap it. The tapped item now becomes the focus item and moves automatically to the center of the view. Fisheye distortion. The concept of the fisheye lens is based on the distortion of a wide-angle lens that shows the focus in detail and the remote regions in progressively less detail. Compared to the zoom interface, the fisheye has the advantage that both detail and context can be integrated in a single view at the same time. To remove visual clutter, users first hit the box icon button below the diagram. They can now draw a bounding box denoting the region of interest. When the pen is lifted, the application centers the focus region and magnifies it in a smooth animation. The surrounding regions contract. Objects that are not in focus are still visible but allocated less space. In contrast, items in the focus region drift apart. Depending on the given information density, users may have to apply the fisheye distortion recursively to isolate items. Panning is implemented as rather conventional drag and drop. Users can understore the diagram by tapping and holding the button with the magnifying glass and the minus sign. To access the details of a book item, users tap in its vicinity. The item closest to the pen position zooms to full screen and presents the book information on the familiar record card representation. By tapping anywhere on the record card, the item zooms back to its original 1 pixel size and position. In this way, the details of any non-overlapped item can be accessed regardless of whether the interface is distorted or not, and regardless of whether the item of interest is located in the focus or context region. Both the geometric semantic zoom and the fisheye distortion feature 3 dynamic query modules. Users can set filters by ticking checkboxes or modifying a range slider. To compare the interfaces in terms of usability, we conducted an experiment with 24 participants in which users had to complete various search tasks on a simulated PDA interface. The results are presented in the corresponding paper.